In this short video, we're going to talk about frame rates and timecode. Part of this is understanding the historical evolution of how we got to where we are today. So in the 1880s, the late 1800s, when silent films were commonplace, 16 frames per second was more or less the standard. The way your eye works, somewhere around 11 or 12 frames per second, you stop seeing individual still pictures and you begin to see continuous movement. It's an optical illusion, of course, but it's reality. Making motion pictures costs money, and particularly in the days when you're talking about film, one of the large expenses was the film itself, particularly when you had to distribute it. So what filmmakers wanted to do was make sure that the film was fast enough that the illusion of motion was preserved, but not so fast that they were wasting money. Right? There's no need to have a frame rate of, say, 40 or 50 frames per second when 16 frames per second would do. So this was standard-ish until the next evolution of technology. With the addition of sound, now a number of technologies were tried, and what ultimately worked out was recording the soundtrack as an optical track on the film itself, so that as the film was being played by the projector, not only were the images being displayed, but the sound was coming off the same film. It stayed synchronized that way. An issue that they ran into is at the relatively low speed of 16 frames per second, the audio fidelity was terrible. It was very muddy. There was almost no high-end response. Everything was just bass and mud. So the frame rate got raised. Now again, Hollywood being a very cost-conscious, profit-oriented organization, all they wanted to do was make money. So they didn't push the frame rate any higher than they needed to, and around 24 frames per second was where the audio quality was deemed acceptable. So that became the new standard and stayed that way for quite a while. In 1941, the NTSC finalized the standards for broadcast television, black and white television at the time. Amongst the specifications was the frame rate of 30 frames per second. This was done for a number of reasons, but it also worked out really well with the idea of Hollywood films being broadcast on television. Even though Hollywood films were 24 frames per second and television was 30 frames per second, they both were multiples, even multiples of each other. They're both multiples of 6. So transferring from 24 to 30 was doable and not all that difficult. Then in 1953, the NTSC finalized the standards for color television. They had to work around a couple of limitations. The federal government mandated that whatever system color television used, it could not make the existing black and white television sets in the market obsolete. Simply because we were adding color, we couldn't force everybody who had bought a television to have to go out and buy a new television. They had to maintain backwards compatibility with the existing black and white 30 frames per second system. To make this work, the frame rate for color television was reduced ever so slightly. From an honest 30 frames per second, it was slowed down to 29.97 frames per second. That sounds insignificant, but it really has caused a lot of problems ever since. There was a bit of an unanticipated consequence in that now Hollywood films at 24 frames per second did not transfer nicely to the new 29.97 frame per second standard. So in order to make sure they didn't lose the television audience, Hollywood wanting to make money by having their films run on broadcast television, Hollywood slowed their standard frame rate from 24 frames per second down to 23.976 frames per second. So 23.976 and 29.97 are multiples of each other. One is 1.25 times the other, same way it used to be with 24 and 30. So at that point, we had 4 competing standards. You had a perfect 24 frames per second with the Hollywood films, and the slightly newer 23.976 frames per second. And then you had the original 30 frames per second broadcast television that still worked for black and white, and the new 29.97 frames per second. The rest of the world paid attention to what America was doing and decided it was really silly. So in Europe, they came up with their own standard called PAL, phase alternating line. The PAL standard runs at 25 frames per second, and it's an honest 25 frames per second. It was built that way from the ground up to be color television at 25 frames per second. And likewise in Europe, films were shot at 25 frames per second. So they only have one standard. What a simple and brilliant way to approach things. The Soviets came up with their own system as well. Well, actually, the French came up with a system that the Soviets absconded with, but it too made sense in ways that the American system didn't. And the world limped along like this with 5 different standards, 6 if you count the Soviet standard, for moving pictures. And these are not necessarily standards that played well with each other. As we moved into the 1990s and digital media started to really become a thing, especially digital broadcast television started to become a thing, we had an opportunity to fix all of this. The Advanced Television Standards Committee was formed, and they began reviewing the various standards that the world was using. Rather than select a single standard, or rather than create a new standard, what the ATSC ended up doing is formalizing every existing standard, plus adding a couple. So as you can see from the slide, we now actually have 8 standard frame rates to choose from. And not all of these are compatible with each other. Things that are integer-based, like 24 and 30 and 60, you can kind of move back and forth between them without too much difficulty. Things that are fractional, like 23.976, 29.97, 59.94, you can kind of move back and forth between those without too much issue. But moving back and forth between fractional and integer rates is a pain. It doesn't work well. Here you can see what the different frame rates are used for today. If you're shooting a film, in the sense of a cinematic release, you have to make a decision if you want it to be compatible, future compatible with television broadcast, or if you're making it just for release in the cinema. If you're going to go down and sit down at Ward Theater and watch it on the big screen, 24 frames per second, an honest 24 frames per second is the way to go. If you're hoping to have it released on video afterwards, 23.976 is the way to go. If you're looking at overseas distribution, 25 frames per second, that's the standard. Whether it's film or video, they use it for the same. They use the same number for both standards. If you are working in video and your primary distribution is going to be video, you have to ask yourself, is it going out on broadcast television, cable television, or is it going directly to the internet and nowhere else? If you're going the broadcast route, if it's going to be aired on a TV station or carried by a cable channel, it needs to be 29.97 frames per second. If you're doing a direct-to-internet release for a YouTube channel, it can be an honest 30. Higher frame rates, 50 and 60 frames per second, are now becoming very popular with a perception of higher quality. But again, you have to keep in mind, do I need backwards compatibility with broadcast television, in which case your 60 frames per second becomes 59.94 frames per second? Or is this a direct-to-video, direct-to-internet release, in which case I can go with the true 60 frames per second? And if I'm going overseas, it can be a true 50 frames per second. It's a little bit absurd that we have 8 standards and that these standards are such that they're inherently incompatible between themselves. Moving back and forth between frame rates is really one of the more difficult things as an editor you might ever have to do. So of these 8 possible frame rates, let's focus right now on the 2 that are most common to us as what we're doing is video production. 30 frames per second and 29.97 frames per second. It doesn't sound like much of a difference, but over the course of an hour, this adds up to about 3.5 seconds in difference. And you can see how having something be 3.5 seconds longer than you meant it to be, or 3.5 seconds shorter than you meant it to be, could be a problem in a number of ways. If you were running this on a satellite, right, you're distributing it across the country, people are watching live, and your show turns off 3.5 seconds early because you used the wrong time base, you'll be a little bit annoyed, as will all of your advertisers. Another problem is in synchronization, both in synchronizing the audio and in synchronizing closed captions. Audio sync and caption sync will drift over time if you're using the wrong frame rate. One of the ways to help fight these problems, although it doesn't alleviate everything, is a concept called timecode. Timecode is a numerical value that's recorded along with every frame as part of the metadata. Developed by the Society for Motion Picture and Television Engineers, SMPTE timecode is the standard for NTSC countries, America, and many of our friends and allies. Timecode is just a series of 8 numbers. It's read like a digital clock. The first pair of numbers is the hours. It can go from 0 to 23. The second pair of numbers are the minutes. They go from 0 to 59. The third pair of numbers is the seconds. They also go from 0 to 59. And the last pair of numbers are the frames. And in the case of 30 frame per second video, they go from 0 to 29. It would be different if you were doing 24 frame, 25 frame, etc. But for our 30 frame per second or 29.97 frame per second, they go from 0 to 29. Because we have two different frame rates, though, 30 frames per second and 29.97 frames per second, we can't actually use the same time code for both. The time code will get out of sync with real time if we try and keep them side by side. So a system was developed called drop frame timecode. And this is a little bit mind-bending. But for 30 frames per second, you use a system called non-drop frame timecode. This is a very simple system. Every frame gets a number, and every number is incremented one more than the frame before it. So if you look at the screen and look at the non-drop frame timecode values, you see that we go from 59 seconds and 27 frames to 28 frames to 29 frames to 1 minute, 0 seconds, and 0 frames. And then from there, we move on to 1 minute, 0 second, 1 frame, and 2 frames. It works exactly the way you would expect it to work, exactly the way you would expect a clock to work. Drop frame timecode, though, remember, the frame rate is ever so slightly slower than the other kind. It's only 29.97 frames a second. To keep the numbers lined up so that 1 hour of video shows up as 1 hour of timecode, they skip numbers every once in a while. When you get to 1 minute, there is no frame number 0, there is no frame number 1. So as we look at our drop frame timecode, you can see we go from 59 seconds and 27 frames to 28 frames to 29 frames. Then we jump to 1 minute and 2 frames. There is no 1 minute and 0 frames. There's no 1 minute and 1 frames. 1 minute and 2 frames is exactly 1 minute in drop frame timecode. And then from then it goes on. So every time you come up to a minute, you skip frame number 0 and frame number 1, unless it's a multiple of 10. If it's a multiple of 10, they get a frame number 0 and frame number 1. It's important to be able to recognize which flavor of timecode you're dealing with. And it's in the punctuation. If you're working with non-drop frame timecode, which is an honest 30 frames per second, all of the separators will be colons. So every mark of punctuation in that 8-digit time will be colons separating the hours, the minutes, the seconds, and the frames. If you're working with drop frame timecode, there will be something besides a colon somewhere. Unfortunately, this is not standardized. But if you look on the screen, you can see 3 examples of ways that different manufacturers display drop frame timecode. The top one happens to be the way JVC likes to do it. So if you're using my JVC cameras, that's what you'll see on the display. The center one happens to be the way Adobe does it. So if you're working in Adobe Premiere or any of the other Adobe products, you'll see semicolons replace the colons when you're using drop frame timecode. The bottom one is from a Sony camera, where they just replace the last colon with a comma. If you see a mark of punctuation that's not a colon, you're dealing with drop frame timecode. If you're seeing all colons, you're dealing with non-drop frame timecode. This is the difference between 30 frames per second and 29.97 frames per second. Or if you were doing film, it would be the difference between 24 frames per second and 23.976 frames per second. There are several takeaways from this. Unfortunately, they all fall in that kind of have to memorize it category. There are numerous frame rates that are standard in use in this country and worldwide. You need to be able to move back and forth between them and understand the consequences of doing so. Some of them are integer frame rates, some of them are fractional frame rates. Moving back and forth in either family is kind of all right. So if you're moving back and forth between integer time codes, between integer frame rates, such as 24 frames per second and 30 frames per second, that works fairly well. If you're moving back and forth between fractional frame rates, between 23.976 and 29.97, for example, that works fairly well. If you're trying to move back and forth across those families, though, moving from an integer to a fractional or from a fractional to an integer, you tend to run into problems, as we mentioned before, particularly with synchronization. All video has got timecode embedded in it now. There are 2 flavors of timecode, drop frame and non-drop frame. Non-drop frame is used for integer frame rates. drop frame is used for fractional frame rates. The way to distinguish between drop frame and non-drop frame is in the marks of punctuation used in the display. If it's all colons, it's non-drop frame. If it has any mark of punctuation besides a colon anywhere in it, it's drop frame. This is one of the most frustrating, irritating, and sometimes downright painful technical aspects of working in video production or cinematic production. And it's a problem that's gotten worse over the years, not better. This is not going to bother you in the course of this class. You're working with your camera, you're shooting footage on one camera, you're bringing it into your editing software. Whatever the frame rate happened to be set at isn't going to matter. Your editing software is going to accept the footage, it's going to adjust itself accordingly. Then when you export the file and you email it to me or you put it on your YouTube channel, I'll be able to play it or your YouTube subscribers will be able to watch it. It's just going to work. Nothing to it. There are two situations where this can be problematic. If you're working with more than one camera, if your footage is coming from more than one camera, the odds that the cameras are set to different frame rates is actually pretty high, particularly if you're mixing levels of technology. So if you've got one of my JVC cameras that's shooting at 29.97 frames per second, and you're also using your iPhone as a second camera, but it's shooting at an honest 30 frames per second, you're going to have some issues when you start editing the footage together between the two. The other situation where it can be problematic is if you are distributing your final product to different places that have different standards. So if it's going to both American television and European television, for example, you've got two different frame rates. One of them's integer-based, one of them's a fractional timecode-based. It's just not fun. But by the time that happens, hopefully you'll be making enough money that it'll be worth your while to deal with this. I'm sure you know the John Lennon song, Imagine. I could write a version of that about frame rates and time code. Imagine there's no drop frame. It's easy if you try. I think I'll end there before I make too much of a fool of myself.